Welcome to the deep dive. Today, we're going deep into Chernobyl 1986, a truly momentous event.
Absolutely. And to really get it, you have to start nearby in Pripyat, Ukrainian SSR back then.
Right, the city built for the plant, just 4 kilometers from reactor number 4.
Exactly. And it wasn't just any city. It was meant to be, well, a model city, an atomic utopia, you could say.
Built specifically for the workers, the families.
20,000 people, mostly young, high-rise apartments, good facilities. They even had a brand new amusement park, just about to open for May Day.
Wow, so everything tied to the promise of this safe, advanced Soviet nuclear power.
That was the dream.
So our mission in this deep dive is to unpack how that dream became, well, the nightmare. We want to look past just human error and really dig into the sources on the design flaws, the pressures, the whole lethal mix.
That's vital because the sources make it really clear. Yes, mistakes were made, absolutely. But the fundamental problem was the machine itself, reactor number 4, that specific RBMK design.
Okay, let's get into that. The RBMK, because, like, most people probably think nuclear reactors use water for cooling and controlling the reaction, right?
Yeah.
As a moderator.
That's the standard approach, yeah. Water does both, cooling and moderating. But the RBMK was different. It used water for cooling, sure.
But not for moderating?
No. The main moderator, the thing actually controlling the neutron flow for the chain reaction, was graphite. Huge blocks of it. Basically carbon bricks.
Graphite, which
Yeah.
is really good at keeping a chain reaction going.
Extremely good. So the water is just for cooling. Now think about this. What happens if you lose that cooling water?
In a normal reactor.
Right. In a normal reactor, losing the water, say if it flashes to steam, slows the reaction down. It stalls. It's actually a built-in safety feature, like hitting the brakes.
Okay, but the RBMK.
It was the opposite. Because it's something called the positive void coefficient. Void is just, an empty space, like a steam bubble in the water channels. If the RBMK's cooling water turned to steam, created voids, the graphite moderator suddenly worked even better. Without the water-absorbing neutrons, the graphite just accelerated the reaction dramatically.
So losing coolant makes it go faster.
Exactly. The sources put it perfectly. The design put a speed pedal where the safety brake should have been.
That is fundamentally terrifying. Okay, so we have this ticking time bomb of a design. Now bring in the people the night of April 25th. The sources describe, well, a perfect storm of pressure and inexperience.
Oh, definitely. You had a night shift, Alexander Akimov is foreman, and Leonid Toptunov, who was really just a trainee. They were doing this complex safety test.
That test they weren't really prepped for.
Not fully. And they were under the command of the deputy chief engineer, Anatoly Dyatlov, a notoriously tough, demanding figure.
And wasn't the test itself delayed?
By 10 hours,
Yeah.
which just cranked up the pressure immensely. They had to get it done. Then Toptunov makes a critical error. He lets the reactor power drop way, way too low, far below safe operating levels for this test.
Which should have meant immediate shutdown, full stop.
Absolutely. That was the rule. Abort the test, shut it down. But Dyatlov, he refused, point blank. He was obsessed with completing this procedure.
And this obsession led him to override safety systems.
Pretty much all of them. He ordered them not to shut down. He made them manually pull the control rods, the actual brakes, made of boron way further out of the core than protocol ever allowed.
Just to get the power back up for the test.
Exactly. He even ordered the emergency core cooling system, the ECCS, to be bypassed. Disabled automatic shutdowns. The reactor was essentially flying blind, stripped of its safety nets, incredibly unstable. And Dyatlov forced them to push ahead.
Was that kind of risk-taking normal, bypassing major safety systems?
Not normal, perhaps, but the system allowed for pressure from superiors to override procedure sometimes. Production targets, fulfilling plans. Dyatlov was focused on the test, not the terrifying state the reactor was in. He'd basically blinded it to its own danger.
Okay, so we reached the critical point. It's 1:23 a.m. and 40 seconds. They start the test. Cut the main steam supply as planned.
And the reactor, already unstable, just surges. Power starts climbing uncontrollably.
Yeah.
Akimov, Toptunov, they see the dial spinning. They know instantly they've lost control.
What do they do?
Akimov does the only thing left. He slams the emergency shutdown button, AZ5. It's designed to drop all 211 control rods fully into the core. Instantly kill the reaction.
The ultimate safety measure.
It was supposed to be. But the RBMK had one last deadly trick up its sleeve, built into those very control rods.
Ow!
Well, the rods were mostly boron, the absorber. But to help them slide in smoothly, the very tips, the first part to enter the core from the top, were made of graphite. short graphite tip.
Wait, graphite, the moderator, the
Yeah.
accelerator.
Exactly. So when Akimov hit AZ5 and the rods started dropping in for a split second,
Wow.
those graphite tips displaced the last remaining water at the bottom of the core channel,
Oh no, creating voids.
creating voids and introducing more moderator right where the reaction was starting to peak. It triggered that positive void coefficient. One last fatal time.
The stop button became an accelerator.
Precisely. The power didn't just surge, it spiked astronomically, maybe 100 times the reactor safe limit in about 4 seconds. Two massive explosions. The first, a steam explosion, blew the 1,000-ton biological shield, the reactor lid, straight up through the roof. The second, likely a hydrogen explosion from the intense heat reacting with steam and zirconium cladding, ripped the reactor building apart. It threw burning graphite and uranium fuel, maybe 200 tons of it, high into the atmosphere. The core wasn't just damaged, it was gone, obliterated.
Just horrifying. And in the immediate aftermath, you mentioned denial.
Yeah, it's bizarre. Dyatlov and Akimov, even as they were absorbing lethal doses of radiation themselves, just couldn't accept the core was destroyed. They insisted it was just ruptured water tanks.
And they ordered people to pump water onto it.
Onto the ruins, into the hole where the reactor used to be. A completely futile and deadly order. Cost more lives.
But while they were in denial, others were running towards the disaster.
True heroes. Lieutenant Vladimir Pravik and his crew from the Pripyat fire station, they got the call. Roof fire at the power plant. They went in thinking it was, well, a fire on the roof.
They had no idea what they were walking into.
None. They walked into gamma radiation levels that were off the scale, battling burning graphite chunks, feeling that weird metallic taste in their mouths. Some even saw a faint blue glow in the air. Cherenkov radiation.
Unbelievable courage. Did their actions make a difference?
Critically, they kept the fires from spreading to reactor number 3 right next door. If that had gone up, the disaster would have been even worse. They absolutely sacrificed themselves to contain it, buying precious time. Most died horribly within weeks.
And while these firefighters were dying, the official response
Was tragically defined by Soviet secrecy. The people in Pripyat. They weren't told anything serious for a day and a half. Kids were playing outside. Life went on while lethal radiation fell.
36 hours before the evacuation.
36 agonizing hours. And even then, they were told, pack for 3 days, you'll be back. They left everything. Pets, photos, documents, they never returned. Imagine the psychological impact of that alone.
Devastating. And then came the cleanup effort. The Liquidators.
Hundreds of thousands of people, soldiers, reservists, miners, engineers, doctors, drivers, drafted or volunteered for the containment effort, facing just unbelievable conditions.
There were some incredible stories of specific missions, weren't there?
Oh yes, like the 3 plant workers. Antonenko, Bespalov, and Baranov. They volunteered for what everyone knew was a suicide mission.
What did they have to do?
They had to wade through flooded, highly radioactive basement corridors to manually open sluice gates. The fear was the molten core, the corium, melting downwards would hit the huge pools of water under the reactor.
Causing another massive explosion.
A steam explosion that could have ejected vastly more radioactive material, potentially contaminating much of Europe. These 3 men opened the valves, drained the pools, and prevented that second catastrophe. They knew the cost.
And the biorobots. Sounds chilling.
It was. The radiation levels on the roof were so intense, they fried the circuits of remote-controlled robots they tried to use for cleanup. So the solution was human beings. Soldiers.
Doing what?
90-second shifts. Run out onto the roof, shovel a few loads of radioactive graphite and debris off the edge or into the crater, then run back. 90 seconds was the maximum calculated safe exposure time, but repeated exposures. It was brutal. They literally used human beings as robots. And don't forget the miners. Coal miners brought in from Tula and Donbass.
What was their job?
To dig a tunnel underneath the melting reactor core. Incredibly dangerous, hot, cramped conditions. They dug nonstop to excavate a space for a massive concrete heat exchanger, a cooling pad, to prevent the molten core from burning down into the groundwater. Another act of mass heroism.
The scale of the human effort, the sacrifice, is just immense. How did the rest of the world even find out? Moscow wasn't exactly forthcoming.
No, they tried to keep it quiet initially. It was actually 2 days later, workers at a nuclear plant in Sweden set off radiation alarms on their shoes.
From Chernobyl.
They traced the atmospheric radiation back across the Baltic Sea, right to Ukraine. That's what forced the Soviets to finally admit what had happened. International pressure.
So containment became the absolute priority. The sarcophagus.
Right, the first one. A monumental effort itself. built incredibly fast in just 206 days under horrific conditions. A massive concrete and steel shell entombed Reactor 4 and the melted fuel mass inside the famous, highly radioactive elephant's foot.
But that was always meant to be temporary, wasn't it?
Yes, it was rushed, built to last maybe 30 years. Which brings us to today, or recently anyway, the new safe confinement, the NSC.
That enormous arch structure.
Exactly. One of the largest movable structures ever built. An incredible feat of engineering. It was slid over the top of the old sarcophagus to safely contain the site and allow for eventual dismantling over the next 100 years or so. And surrounding all this, you still have the Zone of Alienation.
Pripyat, the ghost city.
Completely silent, except for nature. It's eerie. Trees growing right through apartment buildings, wolves, wild horses, reclaiming the streets. It's this powerful, strange monument to the initial arrogance of the design, yes, but also the incredible courage shown in the response.
So wrapping this up, what are the really key takeaways for us looking back through these sources?
Well, first, technically it's that positive void coefficient. Understanding how a design could fundamentally fail in such a counterintuitive way. Second, it's the fatal mix, isn't it? Flawed design plus human error plus intense pressure from the system.
And third, the sheer scale of the human response. The liquidators, their sacrifice is almost hard to comprehend.
It really is. And connecting it all, that final detail about the AZ5 button, the safety system itself having that deadly flaw, the graphite tips, that's the chilling irony, isn't it? The button meant to save them was, in that specific situation, the trigger.
A technical failure that led to unthinkable consequences. But it wasn't just technical, was it? There's a deeper failure here.
Absolutely. Which leads to the thought we should probably leave you, the listener, with.
Consider this. The liquidators, through unimaginable sacrifice, effectively bought Europe its survival from a much wider catastrophe. But what was the real cost to those individuals, their health, their families, and how much worse was that human tragedy made by the secrecy, the denial, the way the Soviet system handled information?
That secrecy didn't just delay evacuation. It created a legacy of mistrust and hidden suffering that lasts for generations. Long after the concrete and steel structures like the NSC are built and doing their job, that human cost, amplified by the system, that's the part of the Chernobyl story that's still unfolding.
A profound thought indeed. We'll leave it there for this deep dive. We'll see you next time.